Welcome to your custom-tailored deep dive. We are we're jumping straight into a very specific, highly detailed primary source today.
Yeah, we have a really fascinating one to look at.
We do. It's a journal entry titled Notes on Fishkeeping, Part 238.
Part 238, yeah.
Right, Part 238. And the subtitle is Why My Turkana Pair is Hiding Their Fry, and it's written by an aquarist named Ang.
Which, just right off the bat, sounds incredibly niche, but I promise it goes somewhere really universal.
Exactly. The mission of our deep dive today is to explore how a seemingly simple, everyday aquarium observation like just watching pet fish can actually unlock these profound insights into animal psychology.
And parental protection.
Right, parental protection, and really the scientific method itself, like specifically how we have to be willing to completely shift our hypotheses the moment new evidence presents itself.
It is a remarkable piece of documentation. I mean, on the surface, you might think you're just reading a straightforward, almost, I don't know, mundane log about pet fish.
Just a diary entry, basically.
Yeah, exactly. But as you progress through Ang's notes, it evolves into this real-time unfolding mystery. We basically get a front row seat to a study on perceived threats, environmental manipulation, and it's just a perfect case study in how our initial assumptions about why a creature acts the way it does are often completely upside down.
Okay, let's unpack this. The whole thing starts with the baseline assumption that Ang makes about a specific pair of fish.
The Turkana Jewel Cichlids.
Yes, scientifically known as Hemicromis exul. So these two fish had just spawned. They had babies, which in the aquatic world are called fry.
Right.
And Ang notices the parents immediately move their fry from inside this seemingly safe, sheltered terracotta pot in the tank. Like, this pot was put there specifically to be a nursery.
It's designed to be the perfect secure spot.
Exactly. But instead of using it, they tuck the babies away in a very specific tight spot on the far left side of the aquarium.
Which naturally forces an observer to ask, well, what environmental or biological driver is causing that relocation? Because rejecting the terracotta pot requires a catalyst.
And Ang's initial catalyst, the first assumption they make, is purely genetic.
They assume it's just the fish's personality.
Right. Ang notes that both of the adult Turkana Jewel Cichlids had acted incredibly timid ever since the very first day they were introduced to the tank. You know, they hid, they darted away from movement.
So Ang just chalks this fry-moving behavior up to the species just naturally being shy.
Exactly. It's treated as this inherent temperament, like a hardwired personality trait of the Hemicromis exul.
And honestly, that is an incredibly common trap in observational science.
Really? Even outside of fish keeping?
Oh, absolutely. Whether you're studying fish, primates, or humans, we all fall victim to what's called the fundamental attribution error.
Which is what, exactly?
It's when we misattribute a behavior to a subject's inherent internal nature rather than analyzing the external situational factors.
Ah, I see.
So think about it. It requires far less cognitive effort to just say, oh, they're just born that way, or it's a shy species, than it does to meticulously deconstruct the surrounding environment to find some hidden variable.
Oh, that makes so much sense. It is like, okay, imagine moving into a brand new neighborhood, right?
Right.
And you notice that the people living next door never, ever come out of their house.
Right, they're totally reclusive.
Yeah. You wave at them from the sidewalk and they just immediately close the blinds. It is so easy to assume your neighbors are just intensely antisocial, reclusive people.
You just label them as grumpy and move on with your...
Exactly. But you might be completely missing the broader context. Like, there could be a massive, aggressive wasp nest on their front porch that you just can't see from your vantage point next door.
That analogy perfectly isolates the problem with observational bias.
Yeah.
Because if you assume the neighbor is naturally reclusive, you stop looking for the wasp nest.
Right. The investigation is just over.
Exactly. You stop investigating the environment. And in behavioral ecology, we have to remember that animals rarely expend energy or adopt defensive postures simply because of a vague concept like shyness.
Because it's a waste of energy.
Right. Defensive behavior is biologically expensive. It costs energy, it costs foraging time, and it costs mating opportunities. So if an animal is acting timid, they are almost always responding to a localized perceived stressor.
They're reacting to something real.
Yes.
Well, the cool thing is, Ang doesn't stay trapped in that assumption, which is really what makes this journal entry so compelling.
Ang actually pays attention when the data shifts.
Exactly. The whole shy theory gets completely dismantled by a daily routine. And here's where it gets really interesting.
The feeding routine, right?
Yes. Ang is just going about a normal day, conducting routine feeding. The Turkana Jewel Cichlids are in their tank, and right next to them, in a completely separate adjacent tank, are zebra cichlids.
Okay.
So Aang drops food into the water and suddenly notices the Turkana pair looking incredibly bold.
They aren't hiding anymore.
No, they aren't hiding in the corner with their fry at all. They are actively swimming out, pressing against the glass, and watching the adjacent tank, literally hoping to snag a share of the pellets meant for the zebra cichlids next door.
I love that. They exhibit a complete behavioral reversal.
Yeah, Aang literally writes, "These days they aren't shy anymore and actually wait eagerly to be fed."
Which completely blows up the genetic shyness theory.
Right, because I have a hard time believing that a few pellets of fish food can just magically erase millions of years of evolutionary shyness.
Yeah, that doesn't track.
If these fish are genetically programmed to be timid, they shouldn't suddenly act like outgoing extroverts just because food is in the water. The food motivation completely overrode their supposed natural timidness.
Which means the initial hypothesis is dead wrong.
Exactly.
What's fascinating here is the mechanics of the scientific method playing out in a living room almost by accident.
Right, just by feeding the fish.
Because Aang introduced a new variable, the feeding routine. And by changing that single condition, the true motivation behind the fish's baseline behavior is exposed.
We get to see what's really driving them.
Yeah, we're basically looking at a classic conditional response.
Yeah.
When the environment offers a high-value resource, like dopamine-triggering sustenance.
Food?
Food, right. The reward pathways in the fish's brain overpower the fear pathways. It proves that their reclusive behavior wasn't a static personality trait at all.
So they aren't inherently shy. They are making a calculated choice to hide, and then they make a calculated choice to come out when the reward outweighs the risk.
Exactly.
Which means there has to be a specific, tangible reason they were huddling in the corner and hiding their babies in the first place. Like, if we throw out the shy theory entirely, we have to look for the wasp nest.
We have to move from analyzing the fish in isolation to analyzing the physical geometry of the entire environment. Because in any ecosystem, spatial layout dictates psychological state.
And that leads directly to Aang's massive epiphany.
Right, the realization about the tanks.
Yeah. Aang steps back and looks at the macro setup. The Turkana tank is situated immediately adjacent to the zebra cichlid tank.
Right next to it.
But the crucial detail is that there is absolutely no physical barrier blocking the line of sight between the two tanks.
So they can see everything.
Everything. There are just two glass boxes side by side. And Aang realizes that the far left side of the Turkana tank, the exact specific spot where they tucked their fry away after rejecting that terracotta pot,
Is the furthest possible point away from the zebra cichlids.
Exactly.
So the spatial arrangement of the nursery was actually a highly calculated defensive maneuver.
They were gathering their babies on the far left, specifically to maximize the distance from the neighbors. Because Aang didn't put, like, a piece of cardboard or a visual barrier between the two tanks, the Turkana parents are looking through the glass, seeing the zebra cichlids swimming around, and perceiving them as an active, impending threat to their offspring.
This raises an important question about the profound divide between perception and reality in behavioral psychology.
Because the threat isn't actually real, right?
Right. We have to consider how sensory data is processed in the teleist brain, that is, the fish brain. The Turkana cichlids are reacting entirely to a visual stimulus of danger. Their visual cortex registers a potential predator next door. And that signal immediately triggers the medial pallium, which is essentially the fish equivalent of the amygdala.
So their fear center just lights up.
Exactly.
But wait, they are completely ignoring the reality of the thick pane of aquarium glass separating them. Logically, those zebra cichlids cannot touch them. There are 2 layers of glass and a gap between them.
Well, rationality doesn't factor into survival instincts.
Yeah, I guess not.
Even though the fish's lateral line, which is the sensory organ that detects physical vibrations and water displacement,
Right.
even though that lateral line is telling them there is no physical disturbance in their water, the purely visual stimulus overrides everything. Cortisol just floods their system.
So they are literally stressed out of their minds.
Oh, absolutely. The parental instinct to protect the fry is triggered merely by the sight of danger. It's completely independent of the actual physical access that predator has. Their neurobiology just overrides physical reality.
I really want to stretch that concept out for a second because the cognitive dissonance there is staggering.
It really is.
Imagine living your entire life inside a completely transparent glass house. You are sitting in your living room with your kids, and right outside your window, a massive, hungry predator is just pacing back and forth, staring at
It's
you.
waiting.
Yeah. Rationalizing that the glass is impenetrable doesn't stop your heart rate from skyrocketing. Your primal instinct screams at you to grab your kids, run to the furthest possible corner of the house, and hide behind the sofa.
You'd be terrified.
You are trapped in a state of chronic hypervigilance against a threat that physically cannot reach you.
And that chronic hypervigilance carries a severe biological toll.
It has to, right?
Definitely. Maintaining that level of cortisol, constantly scanning the perimeter, and relocating offspring, it takes immense energetic resources. It is exhausting for the fish.
Which makes the final revelation of Aang's journal entry absolutely wild.
Oh, the twist.
Yeah, the twist. Because this deeply stressful environment, this constant visual threat pressing against the glass, it wasn't a mistake. Aang did this on purpose.
The methodology behind the environmental design was fully intentional.
So what does this all mean? Aang explicitly writes that leaving the tanks exposed to each other without a visual barrier was a planned choice. Aang had read that allowing fish to visually see other fish, even potential threats, can actually induce spawning.
It acts as a catalyst.
Exactly. It can strengthen the bond between the pair. And according to the notes, it worked perfectly. Aang mentions this setup led to fascinating chemistry between the fishes in the tank.
It brought them together.
Right, so is Aang playing the role of a villain here? Or a brilliant matchmaker? Because honestly, this sounds exactly like taking a first date to a terrifying horror movie.
Oh, there's a great comparison.
You know what I mean? You are deliberately using a shared external stressor, like the jump scares, the adrenaline, the perceived danger, to force two people to cling to each other and bond closer together.
If we connect this to the bigger picture, Aang is illustrating a fascinating biological trade-off here.
How so?
Because in the wild, comfort does not breed complex cooperation. Aang intentionally traded the fish's daily peace of mind for their reproductive success.
Wow, peace of mind for reproduction.
Yes. By removing the visual barrier, Aang introduced a mild, chronic environmental stressor. And evolutionary biology dictates that shared adversity, especially the mutual need to defend vulnerable offspring from a predator, requires immense coordinated cooperation between parents.
Because if they don't get on the exact same page, their fry get eaten, the stakes force the teamwork.
Precisely. In cichlid species, biparental care is absolutely crucial.
Both parents have to pitch in.
Exactly. If the environment's perfectly safe, there is actually less biological pressure to maintain a tight pair bond. They don't need each other as much.
Oh, interesting.
But introduce a perceived predator, and stress hormones like cortisol interact with bonding hormones.
Like oxytocin.
Right, the fish homologs of oxytocin and vasopressin. The perceived danger acts as a biological bonding tool, facilitating a tighter pairing and ensuring the parents work together as a unified defensive front.
That is incredible.
Aang essentially hacked their biological imperatives, using the psychology of fear to create life.
It fundamentally rewrites how we think about creating an ideal environment.
It really does challenge our assumptions.
Because we always equate comfort with thriving. We think a completely stress-free life is the ultimate goal, right? For our pets, for ourselves.
Sure, we want them to be happy.
But biologically speaking, a perfectly comfortable organism doesn't feel the urgent need to adapt, bond, or reproduce with that kind of intensity. They actually needed that external pressure, even an artificial, physically unreachable one, to unlock their full behavioral potential as a bear.
The zebra cichlids basically provided the necessary evolutionary friction.
Evolutionary friction, I love that.
It is a really potent reminder of the value of looking past surface-level observations. A less observant aquarist would have just kept calling the fish shy and never understood the complex hormonal and psychological survival mechanics actually playing out in that tank.
They would have just totally missed it.
We have to constantly challenge our initial assumptions if we want to uncover the hidden and often literally invisible dynamics governing an ecosystem.
Because context dictates everything.
It really does.
And as we wrap up this deep dive, I want to leave you with a final lingering thought to mull over on your own.
Okay.
Think back to those Turkana cichlids. A completely invisible glass barrier and a physically unreachable threat profoundly dictated their daily stress levels, their bonding, and their entire way of life without them ever realizing the true nature of their containment.
They had no idea they were safe.
Exactly. So it makes you wonder, As you go about your day, how many invisible barriers or perceived but entirely out of reach threats are currently dictating your own daily behaviors, your relationships, and your stress levels without you even realizing it?